Good afternoon, class. I am your first reporter for real analysis. Um, I'm your instructor for this afternoon, Gustomi Bustamante from Main Campus, BC3 Mathematics. My topic is all about Chapter 1.1 Sets and Functions. Definition. In mathematics, a set is a collection of distinct objects considered as an object in its own right. For example, the numbers 2, 4, and 6 are distinct objects when considered separately, but when they are considered collectively, they form a single set of size 3, written like this: 2, 4, 6. Notation. There is a fairly simple notation for sets. We simply list each element or member separated by a comma and then put some curly brackets around the whole thing. That numbers 3, 6, 91 are elements, and that 3 dots means goes on forever. In short, we can call this one an infinite. Element or member mean the same thing. Why are sets? Sets are the fundamental property of mathematics now. As a word of warning, sets by themselves seem pretty pointless, but it's only when we apply sets in different situations do they become the powerful building block of mathematics. Subsets. When we define a set, if we take a pieces of that set, we can form what is called a subset. So, for example, we have the set 1, 2, 3, 4, 5. A subset of this is 1, 2, 3. Another subset is 3, 4. Or even another 1. However, 1, 6 is not a subset. Why? Because it contains an element 6 which is not in the parent set. Wala tayong makita nga number 6 sa set 1, 2, 3, 4, 5. In general, A is a subset of B if and only if every element of A is in B. Proper subsets is a proper. A is a proper subset of B if and only if every element in A is also in B and there exists at least one element in B that is not in A. 1, 2, 3 is a proper subset of 1, 2, 3, 4 because the element 4 is not in the first set. Empty or null set. It is a set with no elements. It is represented by a curly brackets, a set with no elements. The empty set is a subset of every set, including the empty set itself. Order. No, not the order of the elements. In sets, it does not matter what order the elements are in. Example, 1, 2, 3, 4 is the same set as 3, 1, 4, 2. When we say order in sets, we mean the size of the set. Example, 10, 20, 30, 40 has an order of 4. Functions. In mathematics, a function is a relation between a set of inputs and a set of permissible outputs with the property that each input is related to exactly one output. An example is the function that relates each real number x to its square x squared. A function relates an input to an output. Classic way of writing f of x equal to ... is the classic way of writing a function. Examples: x squared, squaring is a function. X cubed plus 1 is a function also. Sine, cosine, and tangent are also functions used in trigonometry. Function name. First, it is useful to give a function a name. The most common name is f, but we can have other names like g or even marmalade if we want. F is a function name. That x is an input and the result, which is x squared, is what we call the output. We say f of x equals x squared. Example, with f of x equal x squared, an input of 4 becomes an output of 16. In fact, we can write f of 4 equals to 16 because the 4 squared of 4 is 16. So the output is 16. Relating, at the top we said that a function was like a machine, but a function doesn't really have belts or cogs or any moving parts, and it doesn't actually destroy what we put into it. A function relates an input to an output. Example, this tree grows 20 centimeter every year, so the height of the tree is related to its age using the function h. H of age equals to age multiplied by 20. So if the age is 10 years, the height is h of 10 equals to 10 times 20 equal to 200 centimeters. Rules. A function has a special rules. It must work for every possible input value, and it has only one relationship for each input value. A function relates each element of a set with exactly one element or of another set, possibly the same set. Continuation. Each element means that every element in X is related to some element in Y. We say that the function covers X relates every element of it, but some elements of Y must not be related to at all, which is fine. Exactly one means that a function is single valued. It will not give back two or more results for the same input. So f of 2 equal to 7 or 9 is not right, because the squared of 2 squared is equal to 8, which is the right answer of as an output of f of 2. Explicit versus implicit. Explicit is when the function shows us how to go directly from x to y, such as y equal to x cubed minus 3. When we know x, we can find y, that is the classic y equal to f of x style. Continuation. Implicit is when it is not given directly, such as x squared minus 3xy plus y cubed equal to 0. When we know x, how do we find y? It may be hard or impossible to go directly from x to y. Implicit comes from implied words, in other words, shown directly. And that's all. Thank you for listening, and God bless us all.